Next, we're going to talk about ions. So we're going to title this page Ion. So a good place to begin would be a reminder of the definition. An ion is an atom that has a positive or a negative charge. And if you'll recall with the last graphic organizer that we did, when we talked about a neutral atom, we call it neutral because it has the same number of protons which are positive and electrons which are negative, and they essentially canceled each other out to make a neutral charge. Now we're going to see what happens when that's not the case. So when you do not have that charge is either positive or negative. If that charge is positive, then what you have is a cation. So a cation is an atom that has a positive charge. If your atom is negative, then what you have is an anion. An anion is an atom that has a negative charge. So those are some basic definitions, but let's see what those actually look like. So for our neutral atom, we did beryllium, so why don't we just continue with beryllium here as well. So we're going to draw two different beryllium atoms, one on the left, one on the right. And if you'll recall, beryllium has 4 protons and it has 5 neutrons. And those are going to be in the nucleus. And now, just like with our neutral atom, we're going to draw 2 dotted circles around the nucleus. But with our neutral atom of beryllium, we had 4 electrons. But now, instead of having 4 electrons, I'm only going to put 3. And so remember, we cannot put all 3 electrons on the first dotted circle. We can only put 2 on the first dotted circle. So I'm going to put an electron here and an electron there. And I'm going to put my third electron on the second dotted circle. So what I have are 4 protons and then 3 electrons. And then I'm going to represent those with positive and negative signs. So 4 positives is a plus, 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 plus. And with my 3 electrons, I'm going to represent those as negative, negative, negative. And as you can see here, this positive and this negative are going to cancel. This positive and this negative are going to cancel. And then this positive and this negative are going to cancel, which gives me an overall charge of positive 1. This one positive left over. So I'm going to say that the overall charge is positive 1. Since we have a positive charge, this is an ion because it has a positive or a negative charge. More specifically, it's a cation because the charge is positive. So I'm going to come up here and label this as a cation. Now I'm going to do something similar on the right. I'm also going to write the same nucleus, 4 protons, and then 5 neutrons. I'm going to put this in the nucleus. And once again, draw 2 dotted circles. But this time, instead of putting 4 electrons, or instead of putting 3 electrons, this time I'm going to put 5 electrons. So remember, the rule says that for the first dotted circle, I can only put 2. 1 electron, 2 electrons. And then for the remaining 3 electrons, I'm going to put those in the second dotted circle. So you can see that I have a total of 1, 2, 3, 4, 5 electrons. Now, just like down here, I'm going to show how many protons and electrons that I have. I have 1, 2, 3, 4 protons. And I said that I have 1, 2, 3, 4, 5 electrons. So once again, I'm going to show these as symbols. 4 protons, plus, 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 plus. And then 5 electrons, negative, 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 negative. I can now go through, cancel out what I can. Positive and negative cancel. These cancel, cancel, and cancel. So the charge that I'm left with, my overall charge, is a negative 1 now. So this is by definition an ion because it has a positive or a negative charge. And more specifically, it's an anion because it's negative. So this one we're going to represent as an anion.